To give up, you have to be dead, or completely incapacitated.
I don't always attend meetings, but when I do, the first thing I say. So what are we talking about? Agenda. ccna. Python but. DevOps but. Agronom but. Universe but. Now ccna but. Cisco but. Internet layer protocols but. But previously on ready to die. UDP but. User datagram protocol and UDP header. UDP ports. However, this but is now and now as Internet Layer Protocol but. After Transport Protocol has been selected, which is based on whether the communication should be connection-oriented or connectionless, the information is passed to the Internet layer to determine who is responsible for its delivery. A few protocols run at the Internet layer, such as IP, ICMP, and ARP. Now but Internet Protocol but. Internet Protocol provides packet delivery for protocols in higher layers of the model. It is a connectionless delivery system that makes a best effort in quotes. Best effort attempt to deliver the packets to the correct destination. IP does not guarantee delivery of the packets. Packet delivery guarantee is the responsibility of the transport protocols. IP simply send the data. Remember, and never forget, IP is a layer 3 protocol of the OSI model and is responsible for logical addressing and routing. Now but the Internet Protocol but is also responsible for the logical addressing and routing of TCP/IP and therefore is considered a layer 3 protocol of the OSI model. Deja vu son. IP on the router is responsible for decrementing, usually by value of 1, the TTL aka time to live aka time to live a little of th a packet to prevent it from running in a network loop. Once the time to live of the packet is decremented to 0, the router removes the packet from the network and sends a status message to the sender 9 using ICMP. This prevents loops. Windows operating system have a default TTL of 128, whereas most Linux operating systems have a TTL of 64 by default. Now but IP header but. IP header in the packet contains information that helps the packet make its way from the source to the destination. What is in the IP header? Well, glad you asked. Version. Version is a 4-bit field that identifies the version of IP being used, for example version 4 or 6. Header length. Header length is 4-bit field that indicates the size of the IP header. Type of service. Type of service is a 8-bit field that indicates how packet should be handled by the system. If the low delay option is specified here, it means that the system should deal with the packet right away. Total length. Total length is 16-bit field that indicates the size of the packet. Identification. Identification because networks can handle only packets of the specific maximum size, known as a maximum transmission unit aka M2, system may break the data being sent into multiple fragments. Identification is 16 field that uniquely identifies the fragments. IP flags. IP flags is 3-bit field that specifies how fragments are going to be dealt with. A more fragments aka MF flag indicates more fragments are to come. Also a bit known as don't fragment aka DF specifies not to fragment the packet. Fragment offset. Fragment offset is 13-bit field that specifies the order in which the fragments are to be put back together when the packet is assembled. Time to live aka TTL. Time to live is 8-bit field that specifies when the packet is to expire. The TTL is a value that is decremented with every router the packet passes through. When the TTL reaches 0, the packet is discarded. Protocol. Protocol is 8-bit field that specifies what layer 4 protocol, TCP or UDP, packet should use. Header checksum. Header checksum is a 16-bit field that verifies the integrity of the IP header. Source address. Source address is a 32-bit field that represents the IP address of the sending system. This is how the receiving systems knows to send the reply message. Destination address. Destination address is a 32-bit field that represents the IP of the system the packet is destined for. IP options is a variable length field that is used to specify any other settings in the IP header. Boom boom boom. Now but Python but big but. Python, a tool, not a reptile but why oh why Python? What makes Python special? Nothing, my son Holio, but how does it happen that programmers, young and old and superstar, experienced and novice, want to use it? For the money, son. How did it happen that large companies adopted Python? Cheap, but companies saving every penny cheapskate and implemented their flagship products using it? Because it is free, maybe? There are many reasons, aka it is free. But below is a list of so-called reasons besides the main it is free. Easy to learn. The time need to learn Python is shorter than for many other languages. This means that it is possible to start the actual programming faster. Easy to tech. The teaching workload is smaller than that needed by other programming languages. So this means that the teacher could be dumb as flunk and put more emphasis on general programming techniques and not waste energy on exotic tricks, strange exceptions and incomprehensible rules. Easy to use. Writing new software, it is often possible to write code faster when using Python. Easy to understand. It is often easier to understand someone else's code faster if it is written in Python. Easy to obtain, install and deploy. Python is free, Viola, open and multi-platform, and not all languages can boast that. Of course Python has its drawback, too. Really? It is not a speed demon. Python does not deliver exceptional performance. In some cases it may be resistant to some simpler testing techniques. This may mean that debugging Python code can be more difficult than with other languages, but fortunately, making mistakes is also harder in Python. It should also be stated that Python is not the only solution of its kind available on the market. It has lots of followers, but there are many other who prefer other languages and do not even consider Python for their projects. Boom boom boom. Now but DevOps but. Operating system concurrency. Concurrency is the execution of multiple instruction sequences at the same time. It happens in the operating system when there are several process threads running in parallel. The running process threads always communicate with each other through shared memory or message passing. Concurrency results in sharing of resources, result in problems like deadlocks and resource starvation. It helps in techniques like coordinating execution of processes, memory allocation and execution scheduling for maximizing throughput. Principle of concurrency. Both interleaved and overlapped processes can be viewed as examples of concurrent processes. They both present the same problems. The relative speed of execution cannot be predicted. It depends on the list below. First, activities of other processes. Second, the way operating system handle interrupts. Third, the scheduling policies of the operating system. Now but problem in concurrency. First, sharing global resources. Sharing global resources safely is difficult. If two processes both make use of global variable and both perform read and write on the variable, then the order in which various read and write are executed is critical. Second, optimal allocation resources. It is difficult for the operating system to manage the allocation of resources optimally. Third, locating programming errors. It is very difficult to locate a programming error because reports are usually not reproducible. Fourth, locking the channel. It may be inefficient for the operating system to simply lock the channel and prevents its use by other processes. Now but advantages of concurrency. First, running of multiple applications. It enables to run multiple applications at the same time. Second, better resource utilization. It enables that the resource that are unused by one application can be used for other applications. Third, better average response time. Without concurrency, each application has to be run to completion before the next one can be run. Fourth, better performance. It enables the better performance by the operating system. When one application uses only the processor and another application uses only the disk drive, then the time to run both applications concurrently to completion will be shorter than the time to run each operation consecutively. Now but drawback of concurrency but. First, it required to protect multiple applications from one another. Second, it is required to coordinate multiple applications through additional mechanism. Third, additional performance overheads and complexities in operating systems are required for switching among applications. Fourth, sometimes running too many applications concurrently lead to severely degraded performance. So now but issues of concurrency but. First, non-atomic. Operation that are non-atomic but interruptible by multiple processes can cause problems. Second, race condition. A race condition occurs if th outcome depends on which of several processes gets to a point first. Third, blocking. Processes can block waiting for resources. A process could be blocked for long period of time waiting for input from a terminal. If the process is required to periodically update some data, this would be very undesirable. Fourth, starvation. It occurs when a process does not obtain service to progress. Fifth, deadlock. It occurs when two processes are blocked and hence neither can proceed to execute. Boom boom boom. No Lithuanian trade today also. Yes sir. But a gram but. Day 21. NM, nanometer. NNTP, Network News Transport Protocol. NTP, Network Time Protocol. OCSP, Online Certificate Status Protocol. OCX, Optical Carrier. OID, Object Identifier. OOB, Out of Band. OS, Operating System. OSI, Open Systems Interconnect. OSPF, Open Shortest Path First. Bomb boom boom but. What about Universe? Might be. 250 million kilometers. Asteroid belt. Vesta. Rhea Silvia crater. Vesta's southern hemisphere. 500 kilometers in diameter. 19 kilometer deep. Mountain in the center of the crater is 2 times the height of the Mount Everest, and it is the second tallest mountain in the solar system, taking backseat only to the Martian Olympus. There is also second large impact basin now called Venina. Venina is partially covered by the younger Rhea Silvia basin. These 2 impacts changed the surface of Vesta and probably almost destroyed it. And it remains a mystery how Vesta was able to survive such an extraordinary cataclysm. It is probable that numerous Class V asteroids, debris from the impact, scattered in all directions. Giant impact created dozens of gorges encircling Vesta's equator. Some of these canyons rival the Grand Canyon in size, reaching 465 kilometers in length and 4 kilometers in depth. Massive impact formed Rhea Silvia a mere billion years ago, thus the surface of the southern hemisphere looks younger than the northern, where a tremendous number of craters have been preserved. Boom boom boom. Vesta Vesta Vesta. Billion boom. Bye bye son? Son you sent aka applied to junior position at some bank department. Salary is a 50% cut, damn son. Good job. How you going to survive this haircut, huh? Still you won't get the job. Amazing, right? Maybe for the better. Keep learning. Bye bye.
How love gets the best of us. Yeah, I got feelings, but I'm a tough one sometimes.